So chapter 4 in the textbook, we're going to go through molecules, compounds, chemical reactions, over things. You know, if you hear, remember it. So behavior of matter, so you can blame your behavior. Sound like another. Okay, so exception to molecule. Probably water and other substances. Okay, because it's not a little bit of compounds that are looking at these chemical form. Or okay, use the H2O2 for hydrogen peroxide or H2O. A certain way they're going to, because then we can follow rules. Determine the number of each type of atom as the most 6. Oxygen atoms. That's not so bad. What's a use an electron? Okay, and then the other side is going to probably get an electron and become negative. The charges on those ions, okay? Okay, so we're going to transfer electrons. Okay, molecular compounds. And sharing ionic is all the ones. Yes. Compounds, if we review this again, I and one or more nonmetals. Okay. Got sodium chloride there. Positive. So come together. Show you know their ratio, their 0 because they formed an ion. So if I have anything in the subscript, don't combine with each. So it says show the elements. So crystal molecules compound coming together. That's just like right or some to form an. When I have to come apart because the solution of electricity, so you get into the electrons in a body. Valent. represent molecule. Okay, they can be very small, such as protein. Nonmetals. Compounds are, and then shape, spectrum are going to depend on composing that particular. A molecule can dramatically change the properties of agents. On here. Okay, and I think on Friday, found here, ionic, and which one would be molecular. Okay, so on it. So make A and C. Molecular. You can put okay. We've already got when we're oh, okay, so it's going to be the positive, followed by which is my non-metal. MGBRT. Ionic complexes to indicate what table 4. That without oxygen. Lithium oxide, potassium experts. Line in your. I hope. Am I going too fast? It's Monday. You're not really interested. So there is a single for the whole. Okay, gave them to you. So the sulfate's always going to have a 2 minus. The phosphate's going to have a 3 nitrate. So the whole backside of your so is a unit. Actually have two, but name these. Follow these are and tell me what they are. What's Mg? Is that is O? Do you have your poly? Is OH and hydroxide? Neat. Okay. A is what? No. Right. Is it sulfite has a is okay? So that not have your yeah. It's a less. An ite is an O3. Same thing. Uh, uh, nitrite is an NO2 and a nitrate. Depends on what it's joining with. I the only one that I can come up with now, acetate is an O2, but it's got carbon and hydrogen, so you see it's got more associated with oxide, oxite, they can make it if you're trying to make up new rules of your own. Anyway, let's yep. Sulfate and goes through and bumped out of CaCO3. They're common in product. Fertilizer. Predict to Dr. Grant. There might not break down. Yeah. It's joined to. It is. So that's why I said it, where we looked at that acid, both carbon and hydrogen, and it's an O2, an 8. Got to look on the metal, whether I got non-metal. Oh, we need to go back, because I need to, let's go through this. To get your, okay, so the more that's now use mono, but is it carbon? The ite. That's what I said. The ites are one less oxygen, and the eights. Okay, let's. But the eight. Why is it different? Because of the charge of the first ion. Going with 3 oxygens, 4 oxygens, going with 2. It's in column 6, so it wants to more added, right? What's on oxidation chart? More, but I don't have it in front of me. Okay. So look at the, if it's a +6, let's look at. We've got 3 oxygens on. When you look oxidation chart, can it have charge? In valence. And a little bit more beyond what we always going to be. There. Always. All right, and here oxygen, you got sulfur. Get that right. So until they point, it's not a sulfate here; it's a sulfur trioxide. So it's balanced. When it's got the charge, it's a positive combined because this is by itself. Of it. The mono. And that's why I said that's why we're slowing it with the metals. Where we don't have a metal, the first one's a single. mass of an element of all the atoms in its formula. Something like that. Okay, we took its, right, you take the chlorine, 35.45, we add those up, and the for this add, so then that per mole. So the molar mass of the compound is the conversion factor between grams and moles. Carbonate. Any oxygen. And we're not going to go beyond our quiz. Mole of calcium. I think we're going to. We had quiz too. What if I wanted to? What's the percent? Think of what I would. How much? How hard it is. Okay, I already know. So back to the formula. You can atomic mass of the highly tied. So hydrogen is what? Okay, 30. But that's as hard as it. Remember my formula for hydrogen? It's 34. Will give us in a compound in my lab. So let's try this before we say that we have a sample of 5 grams of. So how many hydrogen atoms are present in the sample? How many grams? The whole looking for mass. 2, 5. Whoops. So it only comes out in red. Great. Hydrogen sulfide is. That's what. And then remember if I times how many atoms there are, and that we have, so we multiply the 6. Multiply the 6.022 mole, and this will give of multiply 6 and first. Making sure you the second. Okay, so what was that? Hydrogen sulfide, there are two molecules. I can't speak today. 2 moles of hydrogen atoms. 5.2 for hydrogen sulfide. We did the same of H. Why say 1 mole of H2S times 1 mole of H2S? Does it show that it has 2 moles of? Does that make sense? It says there's 2 moles of hydrogen. Makes sense, does it? Shouldn't it be 2 up there? That's not right. No, I didn't write that correct. Great. 2 masses. Information off that chart. Using things. So let's skip that example. Okay, that went out. Compound between their chemicals. Further chemical reactions, and then we'll describe those together. We heat things, or we can could be. We have on the left. Okay. And the and here's I think so the number and types of each to be insert here 2 here. So that's how hard it is. You just have to keep the numbers the same, even though it's going to balance. To the reaction of each. We just have to balancing it. If you we balance if the coefficients we always lowest of coefficient whole number. Getting a little bit second. Let's see how many. C3H8 place of methane, which is CH4 for home heating and cooking. It burns and reacts with oxygen to produce CO2 and water. So propane in oxygen is. Okay, so if we just use that, propane goes to the rules that it tells doesn't he's there. Here. Okay. In front of it. Once the L which is my oxygen. If I here and 9. Did I mess that up? No, 10. 0 is 4. So that means I have to have 5 on this side. With here, so I have to have 5 oxygens, carbon dioxides, and 4 waters. And anytime react. Okay, so that's. Let's figure that out. We have a react. Go back to